right. The question says, determine the general solution of 2 sine 2x plus 3 sine x equal to 0. All right. Over here, I'm gonna write. Okay, we want the general solution of this equation. So we're looking for this question. We're doing question 5.5. So we're looking for the general solution for that. For 2 sine 2x plus 3 sine x equal to 0. All right. We can apply some identity here. Okay, because we can see a double angle here. We do know that sine of 2 theta is given by 2 sine theta cos theta. Okay, this is double angle identity. So we can write here 2 times 2 sine x cos x. Okay, plus 3 sine x equal to 0. Now all this makes 4 sine x cos x. For some reason I wrote theta, but I meant x. Just okay. So 4 sine x cos x plus 3 sine x equal to 0. Now we notice that we have we have 2 terms here. This term and another term here, 2 separated terms. Okay, terms are separated by the sign plus or minus. So I can take then I can take sin x as a common factor because they appear both sides. So we can take sin x as a common factor, and then this will become 4 cos x plus 3 equal to 0. Now there's a property in math that says if at the moment that you have a times b equal to 0, this implies that a equal to 0 or b equal to 0. Therefore, we will do sin x equal to 0 or 4 cos x plus 3 equal to 0. Now, we need to find a general solution. For the first one, for sin x, equal to 0, this means that x here equal to what? X equal to in the first quadrant. Okay, we know that this is 0 when the angle is 0 degrees and the revolution will be every 360 degrees. Okay, and now it is also equal to, or if it's 180 degrees and the revolution is every 360 degrees. Let me explain. I'm gonna write, let me just move this over. For sine x, okay, this is for sine x. It is 0 degrees here, and then 0 degrees. Okay, it is equal to 0 at 0 degrees, and it is also equal to 0 by 180 degrees. Okay, so in the first quadrant we say sin x plus x is equal to 0 if I look at the first quadrant only. So it's going to be 0 degrees plus 360k, the revolution, because every 360 degrees the angle comes up to the same value. Okay, now this is the first quadrant. For the second quadrant, it is also 0 at 180 degrees. You can say or x equal to 180 degrees plus 360k. Okay, why K? Maybe K because this is a number. K will determine the number of the revolution because we're talking about the general solution. We don't know how many revolutions will be. Okay, so now here we can just say K is an element, is an integer. Now for cause, okay, for this side we can continue work out this. This means for cause x equal to -3. So cos x will be -3/4, okay? Because we have to simplify. We have to simplify here by 4 both sides. So on the right here, for cos x, let's see in the calculator. I'm gonna press over here. I'm gonna press shift cos of -3/4, okay? So, okay, just the bracket here. And this is equal to 138.59 degrees. So for cos x, I'm gonna write here, okay, cos x will be what? Okay, x will be 138.59 degrees. Because cos is, okay, let me draw a circle here. Cos is 0 at 90 degrees. Okay. This is 90 degrees, and this is 270 degrees somewhere here, where cos are 0. So over here, cos is 0 at 90 degrees. Cos is also 0 at 270 degrees. Am I right? So now, what we're going to do, we say that cos x is 138.59 in the first quadrant. So in the first quadrant, okay, this is not, so this will be, okay, 138.59 degrees plus 360 degrees K, okay? So, okay, this is on the, okay, this is not an acute angle. This is on the second quadrant. But now, if I want to find the other value, okay, I must do here because we do 180 minus this number. So I can just say this minus 180, but I meant to say 180 minus that number, okay? So it's like positive. We're gonna take positive 41. I don't know if it makes sense. Okay, so 180 minus 138.59 will be 41, positive 41.41. So over here, okay, I can say, and this is also equal to 40. I say on the third quadrant, this will be all right, very question here. The question says, determine the general solution of 2 sin 2x plus 3 sin x equal to 0. All right, that's question 5.4.2. So the question says 2 sin 2x plus 3 sin x equals 0. All right. Let's start with the identity here. We do know this because we can notice we have like a double angle here. We do know this identity for double angle when we have like sine of 2 theta. This is equivalent to 2 sin theta cos theta. Okay, we're going to apply this formula over here. So then this will be 2 times 2 sine x cos x, and then plus 3 sine x equal to 0. Now all this combined will make 4 sine x cos x plus 3 sine x equal to 0. Now the fact that we have sine x over here and then sine x over there, okay, first of all, notice that we have like two terms. Terms are separated by the sign plus or minus, okay? This is a product, they are not this, because it's a product, their products here, they all may form one term, all also form one term. Now, because you have like two terms here, we notice that each term has sine x, we can take sine x as a common factor. So this will be like, excuse me, this will be sine x, open bracket like that. Over there will be 4 sine x plus 3 equal to 0. Okay, now there's a property in math that says if we have like a times b equal to 0, this implies that a equal to 0 or b equal to 0. Then this means that we're going to do sine x equal to 0 or 4 sine x, excuse me, I meant here cos x. Here it's cos x. Cos x equal to 0. Cos x plus 3 equal to 0. Now I can move the positive 3 over. That makes 4 cos x equal to negative 3. And then that makes cos x equal to minus 3 over 4. Now these are the solution in terms of sine x and cos x. But now the question is to find the general solution here. When they say find the general solution and we look at the angle, it's x that we're looking for, okay? The value or the values of x. Let me move this over. I want to split this whiteboard like that, so about the 0. So now we have sine x is equal to 0. We need to find the value of x for which sine x is equal to 0. Now, I prefer to do it over here. Let's say here for sine x, okay? For sine x is equal to 0. We do know that sine, if I draw a trig circle here, we do know that sine is 0 at 0 degrees over here and also at 90 degrees. No, at 180 degrees. Okay, those are the places where sine equal to 0. Over here, sine of 180 degrees 0. Then also sine of 0 degrees 0, 0 is 0, not 0 degrees 0. So I will say therefore, for sine x is equal to 0, this implies that x equal to 0 degrees, okay? 0 degrees, because this is where sine x is equal to 0 at 0 degrees. Now, because we're talking about the general solution, we talk about the solution for all the cases. There is a revolution, sine has a revolution of 360 degrees, meaning every 360 degrees, it comes up to, we have like this, we retrieve the same value, okay, of the angle. So every 360 degrees. So here I'm going to say 0 plus 360 degrees k. Okay, k is just a number of revolutions. Okay, after the first revolution, the second, the third, and fourth, and can be as many as possible. K is an integer. Okay, I'm gonna do it after. Or, as I said earlier, sine is also 0 at 180 degrees. So this means that x is also equal to 180 degrees plus 360 degrees, k times k. Here, k is just in an integer. Okay, now for cos x being equal to negative 3 over 4. Now, if I draw my trig circle over here for cos we notice that cos is negative, okay, is lesser than 0 or negative on the second and the third quadrant. So my solution must be over here. This is where cos is negative. Then this is what I want to do. Okay, let's type it in the calculator. So if I do I press shift and then cos of -3/4, okay, close bracket, equal, this is equal to 138.59 degrees. So we say cos x equal to -3/4 implies that x equal to what was the number? 138.59. 138.59. Okay, this, the 138.59 lies on the second quadrant. Okay, so this is going to be degrees plus 360 K, because of the same, it also has a revolution of 360 degrees. Now, now on the third quadrant, then over here, we need to find the reference angle. Okay, we're going to do 180 minus 138.59. So I want to look in the calculator here. I do 180 minus that. But if I do this number, okay, over here, I don't want to press on and then do 180 minus 138. I can just say minus 138, and then take the positive 180. I meant 180. Yes, and then I take 41, positive 41.41. So over here, we can also say that x on the third quadrant then, okay, once I find my revolution, okay, let's just do it. Let's just do it because it might be confusing. I want to do 180 minus 38.59. Okay, then I press SD, we find the reference angle. Okay, so now the reference angle is what I'm going to add to 180 to get the value of cos in the third quadrant. Okay, so now here I want to say plus 180. Okay, plus 180, and then I got 221.41, meaning in the third quadrant where cos is negative, the angle will be 221.41 degrees. It was 0.41, yes, degrees plus 360 K. No, plus 360 K. So K is still an integer. K is an integer. Now the solution here will be we're going to take 360 degrees, okay, because over here it just makes 360 degrees. So 360 degrees K, and 138.59 degrees plus 360 degrees K plus 221.41 plus 360 degrees K. So that's the solution, the general solution of this question. Thank you.